In this section, Indiamoon, we are going to cover how to change the flow of the code in Python. For example, imagine you have some code that you only want to run if a certain value is true, or maybe you want to repeat, i.e., loop, a code as long as the condition is true. Finally, maybe you want to run some code for every entry inside of a container like a list or a tuple. For all of that, we are going to cover some logic in this video. And the most important thing we have to learn about is a boolean value. This is a new data type that can only be true or false. There's no other value possible. The easiest way to create it is with comparison operators like equal to, smaller than, or greater than. Notice, for this one, we are using two equal signs to check for equality, since a single equal sign assigns a value to a variable. Let's play around with all of that. First of all, just to have some basic idea of what's going on, once again we are back in the code and I want to create a new Python file. Let's call it flow.py. Then I can go into full screen again, and now I want to create a basic boolean value. The easiest way of doing that is I want to print some kind of comparison. Let's say 5 is equal to 5. If I run that code, we get the output true, which seems like the correct result for this one. However, if I change this to 4, then we are getting false because 5 is different from 4. However, what you could be checking is if 5 is greater than 4, then we get true once again. So, the result of this operation would be a boolean value, which we can use. For example, imagine we only want to run some code if this kind of condition is true. For that, we have an if statement, which is going to look for a boolean value. For example, we could add in if 5 4, which would be true. And now, pay close attention. If I press enter, Python indents the line by one tab, and this is really important. Let me add one line for now. I want to print correct result with the print statement being indented. This indentation is really important because it tells Python that this print belongs to this if statement. If it wasn't indented, Python would consider it as a general part of the code, meaning it would run regardless of the result of the if statement. As a matter of fact, let me add another print statement that is not indented. So, print, let's say, test. If I now run the code, we can see the correct result. This is what we get from this print statement, and then we get test, which is the second print statement. The first print statement, the one with correct result, only runs because this if condition is true. If it wasn't true, let's say, we can change this to 5 is equal to 4 and run the code again. Then we cannot see the print correct result because the if statement is false. However, we can see test because this one is not indented, so it's not part of the if statement. So, I hope that makes sense. But if you get the basic idea, you understand basic if statements. We add the if keyword, then we add some kind of boolean value. This can either be a boolean value directly. So, if you add if false, this is never going to run, and if you add if true, it is always going to run. But most of the time, you have some kind of comparison. Let's say 5 4, and then it would be running. On top of that, what you can also do is add an else statement. Let's say, we can have print correct result and print incorrect result. If I now run the code, we are getting the correct result because the first if statement ran. However, if we change the condition, let's say 3 4, and run this again, we get the incorrect result since the condition was false. We are running the else statement, and that way, we are getting the incorrect result. And once again, the print statement for incorrect result is indented, so Python knows it's part of the else bit. What you can also do is set an elif statement. The way it works is we first of all check if a condition is true. At the moment, this one would not be correct. Then we can check for another condition. Let's say to 1, and if that is the case, we need to use a double colon. Again, we can print, let's say, some other result, which in this case would run because 2 is indeed greater than 1. However, if that wasn't the case, we would go to else. Let me run all of this. We are getting some other result because for the elif statement, the condition is true. If it wasn't, let's say 0 1, we would simply end up with the incorrect result. You can expand this system quite a bit. For example, you could have multiple elif statements. Let me duplicate it and add it like so. We can, for example, check if 0 is equal to 0, and this one would be true. So, we are getting some other result. The if statement would end on this bit. You can also chain different parts together inside of an if statement, meaning we only want to, for example, run this elif statement if 0 is equal to 0 and let's say 5 1. Only if both of these values are true, then we are going to run this elif statement, and something like this could be done for every single if statement. Also, what you could be doing inside of any of these if statements is add another nested if statement. I could add if and then add another condition, and you can be quite fancy with your conditions. For example, what you could be checking is the length of some list with elements 1, 2, and 3. If that list's length is greater than 2, then we want to do something else. Let's say print list is long enough. Now, if I run the code again, we get list is long enough because this condition and this condition are correct, so we are printing this bit. Then we are running the other if statement, and we are getting to this print statement. I think the logic for all of this is fairly straightforward. There isn't that much to it. The main thing you have to understand is that you always need an if statement, then a condition, and then you want to indent whatever code you want to run by one tab. The code you can add is basically whatever you want. It could even be another if statement or some function or method or list or dictionary, literally whatever you want. Python is super flexible. And with that, we have covered if statements. That is basically all you have to know about them. Next up, we have a while loop. This one is going to run a code as long as a certain condition is true. And to work with all of that, I am going to comment out all the things we have done for the if statement. For example, what we could be doing is, first of all, I want to have some kind of counter which is starting at 0. Then I'm going to use the while keyword. This one, like if, wants to have some kind of condition. For example, let's say that the counter is smaller than or equal to 10. If that is the case, we want to print, let's say, we want to print the counter. And after that, we want to increase the counter by 1. Now if I run this again, we are getting numbers from 0 all the way to 10, and then the while loop stops. We are checking this condition, and as long as the counter is below or equal to 10, we are running the code inside of it, which is going to print the number and then increase the counter by 1, which is going to run 10 times from 0 all the way to 10, and then it stops. Or rather, we go to the line after the while loop, and there we can print while loop has finished. Now let me print it again, and we get, at the end, while loop has finished. Once again, indentation is really important. This print statement and this counter are part of the while loop because of the indentation. Indenting things in Python is fundamental. That way, you know a line of code belongs to an if statement, a while loop, or later to something like a function or a class. Also, what you could be doing in there is add an if statement. So if the counter is equal to 5, then I want to print, I don't know, counter is 5. If I now run this again, we can see on number 5, counter is 5. And if I had spelled this correctly, this would also look much better. But anyway, you know it's working perfectly well, and that is basically all you have to know about while loops. They honestly are not that common in Python. Also, you really want to be careful with them because if you up, this while loop is going to run forever and might crash your code. For example, if you forgot to add this counter plus is equal to 1, let me comment it out actually, and now run the code, it is going to run forever. We are getting a 0 eternally. We are never going to reach this print statement or any code we had after this while loop. If you ever ended up in an infinite loading screen, this is what might have happened. So be careful when you are using while loops. You always want to have some kind of escape condition, which in our case is counter plus is equal to 1, but that's about it. While loops aren't that complicated. Finally, we have a for loop. A for loop is similar to a while loop, except that this one is only working for every single entry of some kind of container. Let me create a test list, which is going to be a list with 1, 2, 3, 4, and 5. The way a for loop works is with the for keyword, and then we need a certain kind of name. Let me, for now, say for x in test list. What is going to happen is that Python is going to go through every single item inside of the test list, meaning 1, 2, 3, and so on in our case. And then, on every single loop, it is going to store that value inside of this x, or whatever you name the value. Basically, we are creating a variable for the duration of this for loop and storing the current item we are looking at inside of this variable. That way, we can easily use it inside of this for loop. For example, we can print x. If I run the code now, we are getting the values from 1 to 5, exactly what I have specified inside of the list. Also, if you are only seeing zeros in the terminal, then the while loop is still running. For you to end that one, simply press on the trash can symbol. That way, you are ending the code, and then run everything again. It should work just fine. Cool. But in our case, we have a simple for loop where we can execute some code for every single item inside of any kind of container. This is going to work with a list, a tuple, a set, and a dictionary. In fact, let me create a set really quick with 1, 2, 3, and 3, and once again, we are getting the values from 1 to 3. Remember, a set ignores any. If we have duplicate values, we can create a tuple with 1, 2, 3, and 3. Then, we are getting all of those values. If we have a dictionary with a couple of key value pairs, let's say 1 and 2, then we have 3 and 4, and we have 5 and 6. If I now run it, we only get 1, 3, and 5, which are all of the keys of the dictionary, which is not necessarily what you want to get for that inside of a for loop. Especially for a dictionary, you have a couple of methods that are super useful. Those would be keys, and don't forget to call this one. This one would only return the keys of the dictionary. Meaning if I run this again, we are getting the same outcome because this is the default value. However, what you can do is values, that way you are getting only the values. And on top of that, there's one more method called items, and this one is returning both, meaning we are getting a tuple with the key value pairs, and then we have access to the entirety of the dictionary inside of one for loop. But other than that, you can still run whatever code you want inside of the for loop. In that regard, it's very similar compared to while or if, so not that much new stuff to learn. For example, what you could be doing for this x, you could use indexing where we only want to get the first item. Then I can print this again, and now we are back to only getting the keys of the dictionary. I suppose there's one more thing that you do want to be aware of with a for loop, and that is that at the moment we are always getting a key value pair inside of a tuple, meaning we have a tuple with always two items. Since this is a bit annoying to work with a single variable, Python has a nice feature where if you know the length of the tuple you are getting returned, or more generally if you have any kind of data structure where you know the amount of items inside of the container, then you can unpack the items right away. So in my case, I know I always get the key and a value. K and V for short. I can unpack both of them right away inside of the for loop. That way inside of the loop, I can get access to the values much more easily. I can print K and V, and the result would be that I have access to the values individually. Especially for more complex for loops, this kind of system can be really handy to work with. But alright, with that, we have the three major tools that you can use to control the flow of the code, and also you can combine them. Now, before we go to an exercise, there's one more really important concept that I want to cover. So far, we only use the basic comparison operators. But in Python, you have another concept, which is called truthy or falsy, which are the result of an automatic conversion of any data type to a boolean. So what does that mean? Well, basically in Python, every empty container, every string without a letter, and every zero is going to evaluate to false. Everything else is going to be truthy. If you add a zero into an if statement, Python needs to figure out what it's going to do, and for that, we have truthy and falsy, where a zero inside of an if statement is going to be a false value, or it's going to be the equivalent of a false value. Let's play around with that really quick. Back in the code, I want to comment out the for loop and instead add a comment for truthy and falsy. Basically, imagine you have the case where if 0, and then you want to print, I don't know, something doesn't really matter. This might seem weird, but if you have 0 and I run the code, we don't get anything because 0 is what Python considers to be falsy. It would evaluate to the equivalent of false, which for Python means that we are not running the if statement. However, if you change the 0 to a 1 and run all of this again, we are getting something because a 1 in Python is truthy, meaning if you put it inside of an if statement, the code is going to run. To organize all of this a bit better, let me change this to something to true and then add an else statement for falsy. That way, we can very easily tell if a value is truthy or falsy. For example, if you add an empty list, so a list without any value and run the code again, we get falsy because a list without a value is going to evaluate to false. However, if you add any kind of value, let's say a 1, then we are getting truthy because any kind of container with any value is going to be truthy. Finally, the last thing is you could create a string without any values. This one would be falsy. However, as long as you have any kind of content, even a single letter, then you are going to get truthy. The logic is going to become intuitive quite fast. The main thing you have to remember is that the only values that are becoming falsy are empty containers, strings without letters, and the number 0. Everything else will be truthy. You only really have to learn about 3 special cases. Everything else is going to be true. And for completion's sake, there are a couple of functions that return either true or false. Any and all are the most common ones. Both of those want to have some kind of container as an argument, and if all of the values, for example, for the all function, are true or at the very least truthy, then it is. The any function is going to return true as a result. For the any function, it is going to return true if any value inside of the container is a true or truthy value. Those are ultimately fairly simple functions, so I don't think we have to practice them. Instead, I want to do an exercise. I want you guys to create a list with the values from 1 to 5 and then run some code for every single item of this list. If the value is 2, then print the value 2. If it is not, then print the value is not 2. Finally, if the value is 5, run a while loop to print last item 6 times. Pause the video now and try to figure this one out. Back in the code, I want to comment out the truthy and falsy bit and instead add an exercise part for this one. First of all, we will need an exercise list 1, 2, 3, 4, 5, and that's all we need. This could also be a tuple, and I realized on the slide I have used parentheses instead of square brackets, but the difference isn't going to matter. Next up, I want to create a for loop. Let's say for x in exercise underscore list, and then I can print the x value. And now if I run the code, we are getting the values from 1 to 5. That's a really good start. After that, in the indentation of the for loop, I want to check if x is equal to 2. If that is the case, I want to print the value is 2. However, if that is not the case, else I want to print the value is not 2. Let's run this one again, and we get the value is not 2, the value is 2, and that is only happening if the value is indeed 2. Other than that, we get the same outcome, which is the else statement. Finally, we have to create a while loop to print last item 6 times. For that, we will need the while keyword along with some kind of condition. The condition in this case is going to be, let's call it the exercise underscore counter, which is going to start at 0. And I want to check if the exercise counter is smaller or equal to 6, and if that is the case, I want to print last item. Really important, we have to increase exercise underscore counter by 1, otherwise, this while loop is going to run forever. And now if we run all of this again, we are getting something weird. We start with the value is not 2, which is this if statement. After that, we get last item a couple of times, and after that, we get the value is 2, and then the value is not 2 multiple times. We never see last item again. So, what happened here? Once you think about it, it actually makes a lot of sense. We start with the for loop, and then on the first iteration of the for loop, we have x being 1, so we are printing the value is not 2. This is what we have seen. If I go up a bit on this line, after that, we are running the while loop, where we are checking if the exercise underscore counter is smaller than 6. If that is the case, we are printing last item, and then increasing the counter by 1 on every single run of the while loop. The issue is that we are running all of this on the first iteration of the for loop, meaning after the first for loop, the exercise underscore counter is going to have a value that is greater than 6, meaning this one is not going to run anymore after the first run of the for loop. As a consequence, we cannot see it anymore, and it's not going to have an impact. The thing we actually want to do if we want to have last item at the end of the for loop is we have to make sure that the while loop is not indented. That way, we are getting the value is not 2, the value is 2 for every single one of the items, and then we get last item after the for loop. This might have been a little bit tricky, but I hope you understand the logic. It's a really good way to practice indentation. Anyway, with all of this, we have a lot of control over the execution of our code.